So this question asks us to solve by substitution. So the first question is, what should I do first? What's the first step? Now, normally in substitution, you want to isolate a variable. It doesn't technically matter which one you isolate, but sometimes there is one that's easiest to isolate. And the one that is mostly already isolated, which is this, is the easiest one. So I'm going to isolate y in the first equation. So if I do that, then I can move the 4x to the other side, and you're going to have y is equal to negative 4x. Once I have that, I can use the second equation. And instead of writing y in the second equation, I can substitute the expression that I isolated. It's important to understand why we're doing this. We do this so that we can get an equation in only one variable. And now we've gotten rid of our y's in this equation and we've only got x's, which means that now we can solve it. So we can continue to solve for x. And if we divide both sides by -9, we are going to get that x is equal to 0. You then have to find y. So it doesn't matter which equation that we use to find y. I could use this one. I could use this one. And I could use this one. But you just want to choose the easiest one. And I think that this is the easiest one because y is already isolated. So I'm going to use that one to find y. So y is also equal to 0 in this case. And here's our final answer, 0, 0. You can give it as an ordered pair, or you can give it as x comma y. So we're asked to solve the exact same thing, but instead of substitution, we're asked to solve by elimination. This is the one where you add or subtract the equations and try and knock out a variable or get a variable to cancel out. Unfortunately, if we just add or subtract these right now, we are not going to be able to get a variable to cancel out because we don't have any matching terms. So the first step would be to multiply an equation by something to get a matching term. So I had students suggest that we could multiply the first equation by 4. Now, while that would absolutely work, so I'll say I'll multiply equation 1 by 4. I'll show you what I will get in that case if I decide to multiply by 4. So I'll multiply this entire equation by 4, and I'll have 16x plus 4y is equal to 0. And then in the bottom, I'll have 7x plus 4y is equal to 0. If you wanted to subtract these equations right now, you absolutely could do that. My preference, though, is to make the multiplier negative to begin with, because if I make the multiplier -4, then we're going to have negative 16x minus 4y. And I just like to have my matching terms be opposite signs, because if I do that, then I can add the equations instead of subtracting them. I just know that I'm going to make a mistake if I start subtracting equations. So this is my preference. Negative 9x equals 0, and x is equal to 0, just like it was in the previous one. And again, you can solve for y, but in this case, we don't have an equation with y isolated. So we're just going to use the first equation, 4x, 4 times 0 plus y is equal to 0, and y is equal to 0. Okay, so same answer as before. So for solving by elimination, what we want to do first is we want to look at this and ask ourselves, can we make a matching term? Can I multiply this term by something to make it look like that? And while it is always possible, there's some ways that are easier than others. So for example, if I multiply this term by 2, it will match this, but there's no easy way to turn 3 into 5. So I'm going to choose to multiply the bottom term or the bottom equation by 2. And I will choose -2 just to make them equal. But if you want to do 2, you can do it that way too. So the top equation stays the same. And then the bottom equation, -4x plus 10y equals -2. So don't forget to apply the 2 to every single term. Then I can add the equations. And look, these are opposites, so they just cancel out. These, the y's, are going to end up 7y. And over here, I'll have 7. So I can divide both sides by 7. And y is equal to 1. So then I can take that 1 and insert it into one of these equations, doesn't really matter which one, to try and solve for x. I'll add 3 to both sides. So x happens to be 3. And there's our final answer. The moral of the story being, you need to look at which equation is easier to multiply by and choose the variable that's going to be easier to kill off first. That is, if one of them is a multiple of the other, if the coefficients are multiple, then those are going to be relatively easy to cancel out. So this question asks if the system can be solved by elimination. Most students in class said that it was possible, but they would prefer to do it by substitution. So I'm just going to give you a quick rundown. If it asked you to solve it by elimination, how you would do it. So the first issue that we have here is that the equations are not laid out the same way. The equal sign is here in between the x and the y, and in this example, the x and the y are over here. So if you wanted to do by elimination, you cannot just add or subtract the way it is. You have to actually make the equations the same format. So to do that, I'm going to move the 8y over to this side, and I'm going to add a constant 0. And I'm going to put 0 on that side. The reason I'm doing that is so that it matches the format of the bottom equation, where each of them have something, a matching term that they could in theory add or subtract by. Okay? So if you have this, now we can add or subtract, but we don't have any matching terms. And in fact, it's not really easy to multiply this to get that or this to get that. There's just not an easy multiple. So when there isn't an easy multiple, then you need to multiply both equations. So I could multiply this one by 4 and this one by 5. I guess I would choose -5 because I'm me. Or I could multiply this one by 8 and this one by 3. And then you would be able to eliminate one of your variables. So either of those would work. I'm going to choose to do it this way. So I have 20x minus 8y plus 0 is equal to 0. And then on this side, negative 20x plus 15y, 17 times 5, 85. So negative 85 equals 0. And then I can add those equations together. And I'm going to have 7y minus 85 is equal to 0. If I continue to solve this, 7y is equal to 85, and y will equal to 85 over 7. And I leave that as a fraction, not as a decimal, unless they ask me to change it. So then you could go through and solve for x as well. So in order to use substitution, you would have to, for part B, you'd have to isolate one of these variables. It doesn't really matter which one because they're equally difficult to isolate. But I could isolate x, for example. I could divide both sides by 5 to isolate for x. And then we would have x is equal to 8y over 5. And then you would plug in this fraction into here. So in the second equation, instead of writing x, I will write 8y over 5. And I will proceed to solve from there. So in some ways, this might be easier with the substitution because you don't have to go through all these steps. You would have to kill your fraction off. So I would now multiply both sides, everything by 5 to try and get rid of this denominator because I don't like doing math with fractions. So then we're going to have 32y minus 15y. 17 times 5 is 85 plus 85 equals 0. And you could continue by combining the like terms. And if you did that, I believe you would still get 85 over 7. So this should be 7y plus 32 minus 15, 17y plus 85 equals 0. So in the green section, I'm just going to finish up here. So I'm going to realize that 17y is equal to negative 85, and y is equal to negative 85 over 17. Now that does not match my original answer in blue because I actually messed something up. So over here, I did not multiply the 8 by the 4, like I said I was going to. So 32 minus 15 is negative 17y, negative 17, negative 17. So if I fix that, then the answers do match up. Student just pointed out that actually this does reduce. So this reduces to negative 5, and this reduces to negative 5. So most students voted that for this particular system, elimination is going to be easier. And there are multiple reasons for that. One is that this is a convenient multiple of 2. I could multiply the bottom by 4. And the other nice thing is that what that would do is it would kill the fraction right away. If you wanted to do substitution, you would probably isolate for y. But if you did that, you're still ending up with a fraction. I'm not going to say it's impossible, it's just not as convenient. So most students would choose to do this one by elimination. So then we're going to multiply the bottom one by 4. Now, normally I would choose negative 4 because I like the matching terms to be opposite. But I'm just going to, for the sake of argument, show you how you would do it if it was the same. So the bottom equation would be 2x minus 4y is equal to 12. And the top equation remains the same. 2x minus 5y equals negative 7. So if you have a match and they are not negative, then you actually have to subtract. And that means that you're subtracting every term. So 2x minus 2x is 0x, so these are going to go away. But then you have to think, what does this red negative do over here? If you're subtracting negative 4 from negative 5, you're actually adding positive 4. So negative 5 minus negative 4 is actually negative 1y. And over here, negative 7 minus 12 is negative 19. So then y is positive 19. So now you guys can see why I don't like subtracting equations, because the double negatives really mess with my head, makes it very likely that I'm going to make a mistake. So if it was up to me, I would just multiply by negative 4 right off the bat, and that way I could just add the equations together. So then if I wanted to find x, I believe the first equation is easier because it doesn't have any fractions in it. 5 times 19 is equal to negative 7. So 2x 5 times 19 is negative 95 equals negative 7. I can add 95 to both sides. And I'm getting 88. 2x is equal to 88. Divide by 2. X is equal to 44. So I have my answers here and here. So the majority of students are choosing to do this by substitution. So I will show you how to do it by substitution. It doesn't really matter which one you isolate, x or y. I guess I'll just isolate y. So y is equal to negative x. So now, instead of writing y, I'm going to write negative x. So down here, 1/2 x plus 1/3 negative x is equal to 1. And that's what substitution is about. You isolate one variable, and then you substitute the entire expression into the second equation. Okay. So now that I have that, I do not like the fractions, so I will kill them all off using a multiplier of 6. You have to multiply 6 by everything. So 6 over 2 is 3x. 6 over 3 is, times negative x, negative 2x. And on the other side, I'm going to have 6. So x is equal to 6. That was actually pretty straightforward. So then to find y, I can choose either equation, but I'm going to choose this one because it's easier, the purple one. Y is equal to negative x. Oh, bam, done. Awesome. If you chose elimination, I believe you could use a multiplier of 2, or you could use a multiplier of 6. But I think it's going to get a little bit messy, because if you use a multiplier of 2, then you're still going to have a fraction left in here. And you can work with fractions, it just really sucks. So I might use a multiplier of 6, and then I would have to also multiply this one by 3 or something, 3 or 2. So I think that in this case, if you voted substitution, you voted for the easier one.